Welcome back, guys. So a while ago, some of you might remember, we had this project of turning this GP3 into a coded siren. So we added the manually activated dampers onto it. We got them working. The plan was always to get electronically operated solenoids on this, so we could operate it off of a controller to do the pulse and the high-low signal. Unfortunately, I've never got round to doing that yet. It's one of those projects that I've been meaning to get back to. But this was always a stepping stone to be able to do it on the much larger GP8 to make a CS8 style siren. So if we look at the CS6, this is a baby brother, if you like, of the CS8. So this is a single-ended siren just with a 10-port end, and it was always designed just to be a single-ended siren on their catalogue. But we have got one of the two dampers, obviously, that would be on a CS8. These are steel tubes wound and then welded onto a flange as well. We've got the box mounted on the side here, and we've got this large traction solenoid here, which is what activates it. So when this is powered, obviously that coiled air will be an electromagnet, and that pulls down this plunger. We've got about 35mm of movement to make the damper fully open, and then when it disengages, it releases that, and this large expansion spring here pulls the whole mechanism back to close the damper again. And you've got this quite complicated set of pins and levers at the top here, which actually makes that system work. So there's quite a lot of engineering gone into that. And if we look inside the damper tube, hopefully we can just see the damper inside there. So when that's open, you can also see actually on the inside of the tube there's an actual cast lip there, which this will actually go down onto and seal the airflow inside. And that's a steel damper flap there, so there's quite a lot of weight in there that it's moving. So from the standard siren without the dampers, on the CS8, having a set of two dampers will about double the length of the siren, from about 600mm up to about 1.2 meters in width, making it a much longer unit. And these also, a pair of these will take the weight of the siren up from about 81 kilos to 125 kilos. So it's a lot of additional weight, so taking it to shows would be a lot harder. So the plan was always to look at a different way of making dampers for the GP8 that would be lighter, a bit easier to engineer, but would still have exactly the same effect. So the first step into making this GP8 into a coded siren was a control panel in order to do all the functions on it. So I've built this new CS8 controller here. This one can do all the damper functions at the top here, and then we've got our siren signal controls down here. So this is a twin voltage input panel, so we can have three-phase 415 volts supplied to it, and also single phase 240 volts as well. The reason I've split it like that, the whole thing can run on three-phase, or if there's a site we go to where three-phase isn't available, we can still do all the damper functions on 240 volt on this panel, and then we can just run the siren up on a 240 volt inverter. So controls at the top here, we've got the damper functions here, so we've got the pulse and high-low signal selector. Down here is our actual siren signals, so we've got the continuous or the attack wail signals, and here we've also got a heater control circuit. So by activating this switch here, we can test the heater plates on the sirens as well. So we've got a 415 volt three-phase input there, so that's a 5-pin, so the three lives, neutral and earth, and then we've got our siren output here. We've also got the 16 amp single phase there, which is for the heater plates, should we wish to test those. And the two 13 amp outlets just down the side there is where each of the damper units will plug into. We've got a light selection on there, so when the 240 volt is connected, we'll get the orange lamp, and when 415 volt is connected, we'll get the red lamp. We've got the blue indicators are for when the dampers are actually powered, and then we've got our two signal indicator lights for the siren signal, and just our heater indicator lamp there. going through what we've got going on inside the control panel here then. So we've got our main three-phase circuit breaker just down here, which is running the three-phase side of things, and just tapped into one of the phases there, supplies a single phase supply through these breakers here, and contactors, which is for our heating system, just popping out in the top corner up here. We've got the main siren motor three-phase contactor just here, and then up on the top bank here we've got our 240 volt damper control equipment. So we've got a earth leakage RCD trip there, and then we've got a selection of single phase circuit breakers here. So we've got a power supply to each of the two dampers there, and then a 6 amp control circuit which is running all the control gear up on the top here. So these units with the red dials on them, that's all our timer relays. So they'll be doing the pulse and the high-low signal timing cycles, and they activate this selection of single phase contactors here. So we've got 2 contactors for each of the damper units, one for the pulse function and one for the high-low, and they feed down into the middle here where we've got our live buses. So we've got a bus for each of the dampers, which are separated there. We've got our main control circuit live bus here, which is feeding all the equipment we can see up here. And then we've got our neutral bus, our three-phase neutral bus, and then our earth bus just down the end here. So what we can do, we can quickly run a bit of power through this just on the 240 volt side, and we can start the attack red sequence on the siren motor if we like, and what we'll see is that big three-phase contactor down the bottom start to jump in and out, and that would be doing the 4 seconds on 4 seconds off cycle to make the motor wail. So that's giving the siren the rising falling note there. And then if we just add a high-low signal, we can see them timer relays at the top kicking in as well, and just hear them smaller contactors going, which will be doing the alternate dampers, one each side, on a 2 second cycle between them. So just showing some of our indicator lights on the front, we've got a 240 volt indicator lit as we're on the 240 volt supply. The heater contactor there would be kicking in with that and firing the heater plates, and then you've got your red signal there where you can just hear the contactor kicking in and out, or you've got the white continuous. And then on the damper side, the high-low, you can see the alternate damper functions there, so that would be sending power to one end and then the other on 2 second cycles. Or you've got the pulse there where both will be running at the same time, making the start stop signal on the siren. So we've been through the much larger tubular dampers which sit on the end of CS8s, and like on the CS6 which we went through earlier, which were made by Secomak and Klaxon in the later Cold War. But there is a different style of damper on it, like on this hand crank here, where we just twist this lever at the top here and a manual flap just closes over there and dampens down the siren sound, which would do exactly the same job for producing the pulse and the high-low signal. Now there is a company out there called Sirenco which does make an electronic version of this for their range of sirens, and I did look at the cost of importing a set maybe to the UK, but they are very expensive to get over here. So I thought we'd have a go at building our own set from scratch. We've got the control panel done, which we've just been through, and I'll just go through some of the process we went through in order to build the dampers for my GP8. The first step in making these dampers was just to pop down to the workshop and do some templates just out of plyboard, just to test that the function would work on the GP8. So the blanking plate here on the right just bolted onto the 12-port rotor just to completely kill that side off, and the vented side here bolted onto the 10-port side, and just did a low speed test, just manually opening and closing that by hand, just to make sure there was enough airflow actually getting into the siren so that it would be able to function normally when it was in the open position. And from there we would then be able to do up the drawings to get the actual dampers laser cut from sheet aluminium. Here we have an assembled prototype damper then. So to get to this stage, the first step was just to do scale drawings with all the measurements that we needed. in order to have this machine made. So the parts manufactured have been the outer wheel here and the inner wheel on the inside here. So these are made from 3mm thick aluminium sheets, which has been laser cut, so it's lightweight, but it's still thick enough to give us the strength that we require. The outer wheel has been pre-drilled, ready to go onto the stator of the siren. So the outer wheel is the static part and the inner wheel is the moving part here. So when the solenoid is activated, this inner wheel will turn, close off the airflow, and when it's deactivated, it will then return to the open position. It pivots on this center bolt just here, which is one of these actual pivot bolts here. So the moving parts will be on this cylindrical section of the bolt at the top here, the smooth part, and then the threads here are what secure the bolts to it, and that's just to help reduce friction in the middle there, so it's spinning on a nice smooth surface. The pin, which has already been added down here for the solenoid gear, so we've got a threaded M6 stud here, and in the bottom half we've got this countersunk bolt here, so it's actually been countersunk into this outer wheel, so again to make sure that it doesn't create a gap between them here and to stop any friction. So that's the bolt head's perfectly flat on the back of that, and then the top bolt will attach to the solenoid gear on the outside. Now this damper will normally be in the open position, and when it's powered it will close, and then when it's unpowered it will return to open. This is the opposite way round to how the Secomak and Klaxon dampers operate. They're usually normally in the closed position when they're not powered, and it pulls them open once power's added. Now the reason I've gone for doing this the opposite way round is if I just want to do the continuous all clear signal or the attack whale signal, which doesn't require the dampers to be operated, I do not need to use them at all. Otherwise, for the minute or 2 minutes I'm doing that signal, the solenoids will need to be constantly active in order to hold those dampers open, and that does cause heat to generate inside the solenoids and shortens their life for running for long periods of time like that. That's also the problem with the Secomak Klaxon style, is if a solenoid does fail, the damper will just remain in the closed position and won't be able to open, and this will mean when that siren is activated it will never be able to reach full power because it will be permanently being dampened down. So this method of doing it the opposite way, just a bit of an advantage over that design. So here we've got the 12-port end of the Secomak GP8, and the way these sirens work, they draw air in through the open end here and force it through the slots on the outside here via these fins you can see on the inside here. As that's spinning, it's just constantly doing that to produce a tone. Now the damper unit we've made will bolt onto the end of this stator here. The outer wheel will cover just to about the edge of the rotor itself there, and then the vented section matches this inner diameter here, and we've tried to put as many vents in there as possible to allow as much airflow as we can get when it is in the open position. Okay, so that's our first damper plate installed on the 12-port end of the siren. It's bolted down nice and tight, so there's no gaps between the stator edge and the edge of the damper plate there. As you can see, the vent slots run right the way down to where the rotor starts, so that's going to give us a maximum amount of airflow in them slots when it's in the open position. And as this is a moving part, this outer wheel, I've just sprayed that red sort of as a warning. So as this is raw aluminium sheet, if you're doing any painting on it, first thing you need to do is a good etching primer there in order for the paint to adhere, otherwise this will just rub straight back off. Next job will be to mount the brackets for the solenoid unit itself to attach to it, and as this siren is bolted down to a trolley which we use to move it around on shows, I think initially I'm just going to mount a bracket onto this trolley just for ease rather than onto the actual siren, so we can get a test rig set up of the solenoid and we can start testing these and make sure they're working. So if we move around to the 10-port side now, as you can see, the damper plate on this side's also been installed, but we've got our solenoid test set up on here. So mounted the bracket just to the trolley at the bottom, just a really simple setup. It's a couple of L brackets from B&Q, which has here in the UK, similar to Home Depot or a store like that. I've put this aluminium reinforcement bracket that I've made myself there, just to keep the whole thing rigid, because this has quite a strong movement on it. And then just an electrical connection box I've picked up from Screwfix here in the UK. So that bolts down onto the trolley at the bottom here, and the solenoid is mounted up on the top here. Now, because this is a 240 volt solenoid, it's high voltage, so I've made sure there's an earth connection there, so that's earth in this entire bracket and the solenoid mechanism as well. So this solenoid itself, as I said, it's 240 volt single phase supply. With the wiring configuration on this, it can run either on 60 Hertz or 50 Hertz. So I've set it for 50 Hertz being here in the UK, but obviously America, a few other countries do use 60 Hertz, so this will work over there as well. It's got 25 mil of movement, and that's what's required to move this damper from the fully open position to the fully closed position. So when that's powered, the electromagnetic force will pull that back quickly, snap the damper shut, and when it's disengaged, that will release and return it to the open position. Now, these solenoids only run electronically in one direction. The return will need to be either gravity or spring. So as you can see, we've gone for the spring option here to get it quickly back to the open position. So we've got a double expansion spring set up here to give enough force to make sure that pulls back quickly, mounted onto an additional pin just on the outer plate here. So this is a non-moving plate here, and that just makes sure the whole thing pulls back to the open position quickly. The other important piece is just this little pivot plate in the middle here. So again, this is just a steel bracket that you can pick up from eBay or B&Q or anywhere like that, and that's there because this is turning the wheel. It will be going uphill as it moves backwards and forwards. So if this was bolted direct to the solenoid, as it would be moving, it would be trying to pull upwards, and it would jam that solenoid mechanism up. So in the open position, you can see it's just running slightly uphill there, and if I put it to the closed position, you can see it's now running slightly downhill. So that's just allowing that little bit of pivot movement, so we've got a smooth motion in opening and closing and no jamming there. So next job will be, we'll hook this up to the control panel that I made. We'll just put it on a pulse cycle, and we'll be able to see this cycling. It should be open for 2 seconds, close for 2 seconds, just repeating that cycle. Got it set up to the control panel now. So what we're going to do, we're just going to run the pulse signal just on the 10 port end at the minute. We've got 5 kilograms of pull force on that solenoid, so what we want is a nice fast snap open and snap close in order to do those pulse and high-low signals properly. So what we do, we just run that cycle for a few goes and make sure we've got a nice movement on that solenoid. For the next test, what we'll do, we'll just put the siren starting to run up. We'll get up to about 10 Hertz on a 240 volt inverter and just hold it there. And then we'll run the pulse cycle again, and we'll just check that we're getting the sound cancelling out of the damper. This is the inverter control panel. So we use this when there's only single phase power available, which unfortunately at my property I don't have 3 phase. So this is what we use to run the sirens up. So the inverter itself is a black unit in the top left hand corner with the flashing red light on. And what that does, that converts our 240 volt single phase to 3 phase 415, which is what the siren motor needs to run. And when that's set to 50 Hertz, it will run the siren all the way up to full max power. Because we're just doing a quick airflow test just on this damper, I'll set it to 10 Hertz, so I'll run the siren up part way, part of its speed, and then it will just hold the siren at that level. Now, normally with 3 phase power, the siren will go from standstill to maximum speed in about 4 to 5 seconds, but running through an inverter, because it's converting that energy via capacitors, it takes longer to charge them up, so it will take about 30 seconds to get one of these sirens up to full power on this control panel. So for this test, what we're going to do, we're only testing the damper on one end at the moment because we still need to put the solenoid on the 12 port end. So the 12 port end, we're just going to close that damper manually, hold it closed, so the 12 port end will be permanently dampened. And what we'll be listening out for is that the 10 port end is that we're getting that distinct change in pitch when the damper's open compared to when it's closed. So we're happy with the function of the damper on this side, so we'll move on to the 12 port side to assemble the solenoid control gear on that side. And what I'll do, I'll film that solenoid gear going together on that side just so you can see how the control gear all gets put together. If we're all happy with that, we're going to do another low speed test, and we'll do the pulse and the high-low signal on that. And then the next job after that will be get it hooked up to 3-phase, and we'll do some full speed testing. Okay, so we're going to start assembling the solenoid control gear for the opposite side of the siren on the 12 port side. So I've just laid out all the different components which we're going to need to complete that side. So obviously we've got the solenoid itself just here. We've got some heat shrink there which we're just going to use to give an extra layer of protection on the cables there, because they just come as singly insulated. We've got the actual mounting bracket here which has already been assembled for this side, so we went through this before. It's just 2L brackets. That's bolted together with 16mm M4 bolts with self-locking nuts on there, so that's just to stop any of it loosening off with that solenoid action. Reinforcing bar on the back, which is just something I made myself in the workshop, so that's just some 2-inch width aluminium sheet there, which was cut to length and then bent in a vise to give us the shape we needed and drilled in on there. We've got the electrical connection box just mounted down the bottom there, that's bolted on through the bottom bolts there. And then we've got the terminal connection blocks which are going to go inside of that. We've already made up the 13 amp supply cable there, 3-pin plug, and that will be our extra earth connection there to earth all this bracket in. Then we've got M8 bolts, and they've got washers and everything else ready on those to go. So that would be for bolting this bracket down to the trolley. Then we've got our 2 springs for the spring return mechanism. We've got our pivoting plate there, so I've pre-drilled that to fit M6 bolts because it could only fit M4 before, and we need M6 to run through the front of the solenoid here. So we've got a long 50mm M6 again on a self-locking nut, and that will be what actually bolts through the front of the solenoid to anchor everything to. We've got our rubber pin here which will be for the springs to connect into the outer plate there, and then we've got 2 other M6 bolts here, and these will go either side of the pivot mechanism just here. So what we'll do, first job to do will be to get this solenoid mounted to the top of the base. We get the earth included on that ready to go, and then this bracket is ready to mount. So we've got the solenoid mounted onto the bracket there, so again we just use those 16mm M4s. We've got the earth in position there, and we've got it bolted down to the base there now. So the only important thing you've got to do is make sure it's lined up, so in a minute that's in the fully closed position with the solenoid closed, so it's in the correct position to start. This solenoid, the problem we did have with it, it only actually has 20mm movement and we need 25. So the way to change that, I've just started to remove the end stop here now, which is set at 20mm, and I'm just going to drill a new hole 5mm over, and that will allow 25mm of room for that damper to open all the way. So that's the next part there. I'm just doing that at the moment, and then we need to take the whole damper off again so we can drill through for the spring pin to go in to align onto the front of the solenoid there. Okay, so then we've now re-drilled and repositioned this backstop here. So in the powered position, this would be the damper now fully closed, and when it goes into its open position, it now has enough room to fully cycle to open. So that's just moving that backstop back by 5mm, just gives us that little bit of extra movement there. So next job, we'll get the pin in around about here somewhere for the spring return. So what we need to do is get the springs mounted on here, get it temporarily lined up, and test the power of the springs to make sure it can pull it back, and then this end plate will need to come off again so we can drill and tap that in there. We've got the pin mounted and the springs in now. All the middle bolts are nicely in and secured, so we've got the full movement on the solenoid from open to closed. So the last job will be now just to do the electrical connections on the bottom, and then we'll give this one a test. So we've got that final electrical connection done on this now, so we've got both dampers set and ready to go. So the first thing is just to test the function of the control panel. So we're going to do 4 cycles of the pulse. So I've borrowed my wife and daughter's makeup mirrors there, so I best be quick with this. So on the pulse cycle, both dampers will operate at the same time and close. They'll stay closed for 2 seconds and then they're open for 2 seconds, and then we'll try the high-low, so that will be alternate, so it'll still be 2-second cycles, but it'll be one end and then the other end. They're all happy that they're functioning correctly, so the next job we'll put 10 Hz through the siren again, and we'll just test both signals with the siren holding at 10 Hz just to make sure airflow's all good. Okay, so we're happy with the damper function, and we're happy the controller's doing what it's supposed to do. There's a couple of little fine-tuning bits I'm going to do here and there, but the next job is to get this over to my friend's house, run it up on his 3-phase supply, and we'll be able to film this going full power. So that will be the next video.